So now we're going to talk about operations on functions, this time dealing with angles. So let's say that I give you something like this. For f of theta, let's say is equal to sine theta, and g of theta is equal to cosine theta. All right, so that's our given information. Find the exact values. Find the exact values of each function. And do not use a calculator. Okay, so let's say that we give you something such as f of 2 theta. So what that actually means is whatever theta is, because 2 is right there inside of the parentheses with theta, we're going to multiply it by 2. So what we're really looking at is, oh, and I forgot to give you something else. Sorry. Use theta is equal to 30 degrees. Okay, so theta is equal to 30 degrees. So now I'm evaluating f of 2 times 30 degrees because theta is 30, which means that I'm looking at f of 60 degrees. Okay, so since I'm evaluating f of 60 degrees, which means that if f of theta is sine of theta, then that means that I'm looking at sine of 60 degrees. Okay, just a quick side note. If you wanted, we could have done this. F of 2 theta, since this is f of theta, right? And I'm multiplying it by 2. F of 2 theta would have been sine of 2 theta, which still would have been sine of 2 times 30. And we still would have gotten sine of 60. So now to finish this out, what we have to do is we have to draw our triangle the way we've been doing, okay, and find 60 degrees. So 60 degrees is in quadrant 1. And so I'm going to go ahead and label that 60 degrees. And it's a special right triangle, so I know across from 60 degrees is a square root of 3. Adjacent is going to be 1, and my hypotenuse is 2. So the sine of 60 has a ratio, and that ratio is opposite over hypotenuse, or if you want, you can write it as y over r. So my y value is square root of 3. My radius is 2, and that would be the final answer. So f of 2 theta is equal to the square root of 3 over 2. Okay? All right, let's move up to do another kind. Let's see. Let's go ahead and look at one that looks similar, but the 2 is in a different location. So let's look at 2 of f theta, 2 times f of theta, which means that I'm really taking 2 times sine of theta, right? Because f of theta is sine theta. So since theta is 30 degrees, that means that this is really equal to 2 times sine of 30. Again, giving you practice with this, so draw your triangle. 30 degrees is in quadrant 1. Okay, we're going to draw that right triangle in quadrant 1. Here's our 30 degrees. It's a special angle, so I know across from it is a length of 1. Adjacent is square root of 3, and my hypotenuse is 2. I encourage you to keep drawing that triangle over and over so that it really is hard to forget. Okay, the ratio for sine of 30 is opposite over hypotenuse, or y over r. Okay, so we're going to have 2 times the y value is 1 over the hypotenuse, which is 2. Okay, which is going to give us 2 times 1 is 2. Or you could, if you wanted to, you could go ahead and reduce right here. This is 1 and this is 1. So our final answer would be just 1. And that's our final answer. Okay. All right, let's do another one. So let's say this time I give you something such as f of theta plus f of negative theta. So this is going to be important because if you remember at the very beginning of the year, this was one of the techniques we used, right? Evaluating f of negative x to find out if something was even, odd, or neither. So that's just kind of a quick connection to what we did at the beginning of the year. Okay, so f of theta is sine theta. Whoops. meant to write theta. Even though theta is 30, but still, sine of theta plus f of negative theta is going to be sine of negative theta, okay? So you are going to have to talk about, is sine an even or an odd function? And we can get to that later. Well, actually, we don't have to get to that later. Let's see what happens. Okay, so watch. Positive 45 is in quadrant 1. Here's my, 30 degrees is going to be in quadrant 1. Okay, and I know across from it is a length of 1, adjacent is square root of 3, hypotenuse is 2. So the sine for theta, which is really the sine of 30 degrees, I keep forgetting to write this, and the sine of negative 30 degrees. Okay, so the ratio for sine of 30 is going to be opposite over hypotenuse, which is 1/2, plus, now let's evaluate sine of negative 30, which it's not in quadrant 1 because I'm starting on the positive x and going clockwise. It's actually going to be in quadrant 4. Okay, so from the positive x down, so that's 30 degrees, right? And it's, by the way, the reference angle for that is just going to be 30. Okay, so you can write negative 30, that's the theta. But when I look at the reference angle, I'm just actually, that's going to function as the reference angle. It's just 30 degrees. Across from it is negative 1 because you're below the x. Adjacent is going to be square root of 3, and then the hypotenuse is 2. So the sine of negative 30 degrees is opposite over hypotenuse, which is negative 1 over 2, okay? Which means that I'm going to have 0 over 2, which is 0. And that would be the solution for that particular problem. Oh. Okay. All right. So another example you could be given is, let's say I give you something like f plus g of theta. Okay. Which, again, at the beginning of the year, we talked about this operations on functions. That really means f of theta plus g of theta, okay? Which means that I'm really looking at sine of theta plus cosine of theta because of the information they gave us. And because theta is 30, this is going to be sine 30 degrees plus cosine 30 degrees. Now, 30 is in quadrant 1, okay? Which means this is 1, this is 2, and this is root 3. All right, so let's get the ratios. So the sine of 30 degrees is opposite over hypotenuse. That's going to be 1/2. Plus the cosine of 30 is adjacent over hypotenuse, which is going to be the square root of 3 over 2. So our final answer is just the common denominator is 2, so we're going to write 1 plus the square root of 3. I can't simplify that anymore, over 2. And you're done. Okay? And then the last example that I give you, let's see if I have enough room. Oops. I don't think I'm going to have enough room, and I don't think I can add a page. Oh, yes, I do have enough room. Okay. So the last example I'm going to give you is something like this. F times G of theta. Again, we did this at the beginning of the year. That's equivalent to F of theta times G of theta. Okay. Which means I'm looking at sine 30 degrees times the cosine of 30 degrees. So 30 again is in quadrant 1. And if this were your problem, you could just continue to look at that one triangle you've already drawn. So this is 1, root 3, and 2. But I think it's a good idea to keep drawing the triangles. Okay, so sine of 30, the ratio is opposite over hypotenuse, which is 1/2, times the cosine of 30, which is adjacent over hypotenuse. So you're going to multiply by square root of 3 over 2. And be careful because this time with multiplication, you multiply top times top, bottom times bottom. So I get square root of 3 over 2 times 2 is 4. And that would be your answer there. You're done.